Hello there. I'm back. It's environmental science time, and I hope you got my message today. I was looking at the schedule and trying to figure out how far behind I was, and I was feeling pretty far behind. And I discovered that when I put the schedule together at the beginning of the semester, I had left April 9th off of the schedule because I was supposed to be at a conference. That's all been canceled, but now it's April 9th, and I find that this is my opportunity to try to catch up because on Tuesday I was supposed to put up two lectures, one on air pollution and one on water pollution, and I only did one. So here's me trying to get back to where I thought I ought to be. And I won't put up a third lecture and I won't put up a lab because that wasn't really on the schedule for this week. So I'm okay with that. I hope you're okay with it too. Anyway, water pollution. Remember we did all the general information about toxicity and finding out how we discover how deadly something is. And then last time I talked about air pollution and what types of pollutants there were being released into the air, having an impact on people. And today it's about water pollution. And we have to go through some of the same process, and some of the things that I talk about may seem a little familiar because we've used these terms before, and now we're into our third lecture about pollution. We got some concepts we can deal with. All right, water pollution. Okay, it appears that I am going to dive right in with a big complicated terminology slide. But I decided that I'm gonna structure around this slide, and I'm going to come back to it and look at different parts of it one at a time. So it may not be as complicated as it looks. This is just like we started with the air pollution, where we said, what are the different types of air pollution? How can we divide it up into categories? And that's what we have here. And I have three ways of dividing up water pollution. The first is by location, and we have freshwater, marine, and groundwater. So freshwater is a stream, a pond, a lake. This is the small amount of water that's actually kind of useful for us. Then there's marine, which is the oceans, and not as useful because of the fact that it's not potable, but clearly it's an important resource, especially when we consider the biological resources that we pull out of it. And then finally there's groundwater. And if you remember when we talked about watersheds and aquifers and how water can move through a system without having to be at the surface, just imagine that water down below is actually polluted if it's toxic, and that's actually fairly common. So that's a big concern as well. The next thing we have here on this list is materials, and that's a big long list here, but I'm only going to draw your attention to three major headings on that list. There are biological materials, there are chemical materials, and there are physical materials. Biological are things that are alive. So some of the stuff I have there is if we have sewage or agricultural runoff or maybe biomedical waste, there might actually be infectious material in that, bacteria, protists, possibly viruses, although again the debate is on whether that's living or not, but still biological materials have the potential to cause diseases. Chemical materials are chemicals that can come from sewage, from fertilizers, from mining, heavy metals and fertilizers and pesticides and oil and solvents, anything that you would have in a can and go, I wonder if I can toss this in the trash. I wonder if I need to get it treated somewhere. Can I pour it down the sink? Should I toss it in the trash? Well, either way, it probably ends up in the water pollution. I'm not really sure how the best way to approach that is. But anyway, if it's chemical and not living, then this is the category it belongs in. And then finally, there's physical, and sometimes there's solid waste that ends up in the water. And all you have to do is go down to the river, down to the shore, and look at all the plastic bags and little bits of metal and plastic, and you'll see that solid waste that ends up there. And there's also sediments when we dig holes, when we're building buildings and making parking lots, sediments end up, and that's very problematic for a lot of ecosystems. And then also under physical, I've also put heat, because there are a lot of industrial processes that use the coolness of the water to control a chemical reaction or to remove heat from from a power generating station or something like that. And unfortunately, that water, while it's warm, goes right back into the cool water of the river or the lake or the pond, and it is in fact toxic to the organisms that live there as a result of that change in temperature. The last list that I have here is sources. This is the longest one in terms of the individual headings there, but I'm going to talk about these in a little bit more detail as we move through. So I'm just going to read them off to you. Agriculture is a major source of water pollution. The wastewater that comes out of urban areas that has to be treated before it's put back in the river, even though it's treated, it still has a lot of water pollution problems that go along with it. Industrial release of water, when there's a factory that's doing something chemical and it ends up using water for that. Sometimes characteristics of that water are dangerous when it's released back into the rivers or ponds. Mine tailings, when we dig a hole to mine up some minerals, some metals, sometimes we end up concentrating things that are very dangerous, and then when it rains into the mine, when it rains on the piles of ore that we leave outside of the mine, the water leaches through that material and it ends up running down into the rivers, into the streams, and that's been a toxic problem for a lot of people. And then finally it says runoff and leaching, and what I'm talking about there is mostly in urban municipal types of areas, runoff from roads, from parking lots, from yards, and leaching from landfills. So this is just rainwater that is being filtered through the city and filtered through the garbage piles that we make, and the water ends up picking up toxins and then making its way to the river. So 5 really big sources of water pollution there. Okay, so now I'm right back to the same slide, but I have a focus here, and my focus is agriculture. I've got a picture here of somebody who's spraying something that's probably terribly toxic onto the whatever crop is being grown here, probably soybeans or something like that, and as a result, there may not be as many little insects chewing on these crops, but this stuff gets into the soil and it works its way across the field and it ends up into the groundwater system, it ends up into the surface flow water system. So that's a problem. So what I've done is I've highlighted the fact that agricultural sources are a big issue for all the different types of locations of water, and some of the places where it tends to show up down here are in the organic load of the water. And that means if there's just a lot of organic stuff in the water, then that means that bacteria that are just trying to make a living in that water will be breaking up all that organic matter. And in the process, they consume oxygen out of the water. And as a result, if there's a lot of organic matter in the water, then the bacteria use up all the oxygen and it becomes very difficult for any other organisms to live there. So other things like fish and small aquatic invertebrates and things that we would like to have in our waterways, they actually tend to die off when there is too much organic matter in the water. We also have from agricultural sources fertilizers that end up in the water. We have pesticides and herbicides, and those are dangerous chemicals. And then finally, we have sediment and possibly some when they till up the plant material, a lot of that plant material ends up in the watershed, and so it kind of has an impact on all these different types of materials. And there's a lot of stuff going on big flat open areas, but all the water that we dump on these fields has to make its way through the soil, through the groundwater, and into the watershed itself. And by the time it gets there, there's usually a lot of problems with it. I tossed in one more picture here just to emphasize the point that I'm trying to make. Here we have some agricultural fields, and it rains, or maybe there's even some irrigation, and the water flows down here into the stream, and clearly the stream is having some serious problems. We have what looks like too many nutrients, too much organic matter, maybe even some chemicals that are killing off some of the organisms that would normally take care of this mess. Anyway, this is from agriculture. There's nothing else in this area that it could be due to. It is clearly from agriculture. Okay, so here we are right back with the same slide, but I hope you can see what I'm doing now. I'm moving on to wastewater, and I'm showing you that that's primarily a problem in freshwater systems. If we look down below, we see that in wastewater, because this is coming from urban areas mostly, and we are flushing our toilets, doing our laundry, and watering our lawns, and all of this stuff is going into the system that drains back into the river eventually, or into the reservoir eventually. Except that it is often treated to some extent, which is what I have a picture of here, a water treatment plant. But water treatment is really just a series of holding tanks and some chemicals that try to get the really nastiest stuff to sink out of it so that we can take it off the bottom before we dump it back in the river. Anyway, I've got some indications down below that are a big problem with wastewater. The organic load, obviously, for flushing toilets and such. The fact that there could be infectious material in that is true as well. The fact that there are a lot of nutrients. Now, I'm not talking about the organic load, but things like nitrogen and phosphorus, nutrients that might actually cause too much algae to grow in the river. Often that's an issue in wastewater that's running back. In addition to dumping waste into the water that we're using, we take a lot of bioactive drugs, prescription medicines, even over-the-counter stuff. And when you take things like painkillers or birth control and things like that, a lot of that just goes right through you. It has the impact it's supposed to have, but it goes right through you into the pee, into the water, into the flush, into the river, because we don't really have any way in our wastewater treatment to actually account for that kind of material. It's not really the stuff that we're trying to clean out of the water. And then finally, down in the physical materials, we have solid waste, because even when we dig a hole and it goes into the street and runs down the sewer, that's taking a lot of material with it, and so there are sediments. There's dumping that takes place in cities. There's heat because we use water for different purposes. We use hot water, and so the water that runs into this system and it's sitting in the sun, it might not be the right temperature when it's dumped back into the river, and it has an impact on the ecosystems there. So anyway, lots of things going on with this wastewater that can be pretty problematic. This is a little diagram of a wastewater system, and I've taken many classes of students to the wastewater treatment plant here in Columbia, and the water treatment plant that prepares the water for our use, that as well. But the wastewater treatment plant is the one out there. It's out there off of Bush River Road, almost where 77 crosses that road there. And it's a pretty bad smelling place, because there are these big open basins that are letting a lot of sulfides and things kind of make their way out of that water. Like I said, it's really just a series of holding tanks. We've got a kind of a cartoon version of it here, going from left to right. We start with raw sewage, and it goes through a screen, and then we grind it up, and then we put it into a tank and let some stuff settle, and we get rid of the grit. That's probably some pretty nasty stuff. Then we let it sit a while longer, and we get more stuff off the bottom of it. We take the water off the top. This is called the primary treatment. And then we put it into a tank that bubbles air through it and gets some bacteria working on it in there. And we're getting into something called secondary treatment. And then we're going to treat that with some chemicals, let it sit in another tank. This is a clarifying tank. Pull the nastiness off the bottom again and send it back through one more time. So there's a little bit of a cycle there. And if it's really nasty, we're even going to send it all the way back to here, or we're going to get rid of it in a solid form. So it's really just letting it separate and taking the different parts away. Then the last step is that we're going to disinfect it with some chlorines probably, and put it back into the system. And that's the tertiary part of this: primary, secondary, tertiary. This diagram down below is a little bit more simplistic, and in my mind, it gave you an accurate depiction of a whole series of different tanks, where sometimes the tanks are designed to stir things up, sometimes they're designed to let things settle, sometimes they're designed to add some materials. And so anyway, that's really the basis of the process of water treatment. Okay, now back to my word slide here, and I've moved on to industrial release, and you can see that that's going to be an issue in freshwater and marine systems, a little bit less groundwater, but that should be changing soon because we are starting this process of hydraulic fracking, which means pumping water down into the groundwater to get oils and things to come up to the surface, and that is putting water into the, basically contaminating water on purpose. I think that the hopeful idea is that they will use a water that's already contaminated to do this. Not that that's a great idea to put that into the groundwater, but if you're going to be mixing it up with oil anyway, and if it's already contaminated, clearly you're losing less of a valuable resource. Anyway, industrial release. And I have a picture over here of, this isn't exactly release, but what it is it's a power station, and water is being used to cool a power generator. And so we have to consider that the production of heat is really an industrial use of water. And it looks like there's a bunch of nasty pollution heading into the air there, but that's really just steam. And it's just a kind of an indication that this water is being heated up. And you can see that there is, it's built right next to a water basin, and that water is dumped into that basin. So the only other thing I have down here is industrial processes usually involve persistent organics. There's a term, persistent organic compounds, POCs. Things like oils and solvents and big organic chemicals that don't just disappear in the world. They cause problems down the line. And also heavy metals, which tend to be involved in a lot of industrial processes. Anyway, so there's a lot of that going on here. And wow, anytime that you see that much water flowing through that many pipes into a water basin or a river, you know that it was being used for some industrial purpose. They're not just redirecting the water and saying, oh, we're taking it out of the river and then we're putting it back in. They're using it for some process in between. Some chemical process that involves water, some thermal process that involves water. So this water has been modified. It's unclear exactly how. I don't know anything about this picture, but it has been modified somehow, or it wouldn't be flowing through those pipes. The next thing on my list is mine tailings, and that is a bit of a problem in freshwater systems, especially near rivers, because flowing water is very important to mines, and also because mines are holes in the ground and they often involve using water to help develop these holes. They have a big influence on groundwater. Here I've got a picture of some type of nasty chemicals flowing out into a river. Because I read the news, I know where this is coming from, and it's the result of a heavy rain with water going through an old abandoned mine, and that groundwater flows out into the river, and it's full of toxins that are problematic. But you only see it when it rains very heavily. That doesn't mean it's not having a huge impact, but you can see in this particular case with the color, that's not the place you would want to go swimming or drinking or whatever it is that water might be useful for. So I have listed down here or highlighted heavy metals because of mining, because of leaching, and then also solid waste because of dumping around a mine, because of sediments, and because the industry of mining involves power equipment and generators. There's often heat pollution that goes on with the water that gets released from these systems. Here's another nice photograph of nasty water flowing down out of the mountains where somewhere there was some type of mining operation. And clearly there are chemicals that are precipitating out. That means they're in such high concentration that as soon as the water starts to slow down and cool down, suddenly they go from being in solution in the water to solidifying into a crystal form. And so it's fairly easy to test to see whether this is dangerous. And I just happen to know that, yes, these are dangerous chemicals. Okay, so this is the last thing on my source list, and this is runoff and leaching. And the The other things on this list, the wastewater, the agriculture, the industry and mining, those may have seemed a little bit removed from our everyday existence, but this is not. This is right on us. Here we have a picture of some area on the side of the street with a drain, and it's oily and it's oogy and there's trash, and that is all just consumer stuff that got thrown on the ground or leaked out of the car, or this is not an industrial process. This is just people living someplace and creating stuff on the surface that when it rains, it runs into the water systems. And so I have highlighted fresh water being the primary problem here. Down below, I say yes, because when it rains, we end up with some of our wastewater material ending up running off into the river systems. Yes, there is microbial infectious material. Yes, there are heavy metals. Yes, there are oils and solvents, as you can see from this picture. There are pesticides because we sprayed them in our yards, and herbicides because we spray them in our parks. There are endocrine disruptors because sometimes when we toss things into our landfill, that leaches out and ends up in the runoff as well. And then finally, there's solid waste, and there are sediments, and all of this is just from runoff on the surface. And because that comes from urban municipal areas like ours, that's really something that we have a lot of control over and we need to think about carefully. And of course, there have been some people thinking about it. Unfortunately, this is usually about as far as it goes. If you drive around the city of Columbia, every now and then you'll see a little spot like this where it says, don't dump anything here because this goes right to the river. All of the grates on the sides of the roads in Columbia go right to the river. They're not pumping that stuff from the city of Columbia all the way out to Bush River Road. It's going right down into the parks where people walk around. So it says here, dump no waste, drains to river, and they got a picture of a fish there. They have different versions of it. Sometimes it's on a little copper plate. Sometimes it's got a cartoon fish, but this is pretty typical. So again, it's pretty important to heed this. But we can see a bigger picture if we take a look at some analysis. And what we have here is a lot of different ways that materials turn into runoffs. Maybe not all in the city, but I thought it was a good way of kind of summarizing what we're looking at here. We have agricultural system. I mentioned nitrogen and fertilizers and pesticides. That's getting into the groundwater, making its way to the river. Even from planes spraying chemicals on the crops. We have industry, chemical spills, PCBs. This is one of those persistent organic compounds. Benzene, we talked about that, even being released into the air being a problematic toxin. We have landfills. Now, in this particular landfill, this looks like a really nasty one, but there are landfills that are just the garbage that we create, and those create nasty runoff as well. We have leaking gas tanks, leaking oil tanks. If you have a drip from your crankcase, and that's every time it rains, that oil runs down one of these grates, then that's a contribution to that problem also. I haven't mentioned it, but there's also when there's things like smog in the air and it rains through that smog, we have a tendency to go from air pollution to water pollution. So what was in one lecture turns into what's in the other lecture, and it does that through this type of runoff situation. And then the last thing we have all the way over here is water treatment. So we're taking water in to the water treatment plant, right? We're making it safe to drink, to take a shower in. We're holding it in a tank until somebody needs it, and then we're going to pump it through some pipes into your house and then out of your house into some place that makes it safe to dump back the same place that it got pulled out of. And that's why it says septic. That's either a septic system or it's a water treatment plant. But I also want to draw your attention to this. It says copper and lead pipes. And that's a big issue right now because in the process of delivering water to people's homes, sometimes the infrastructure that we've put in place involves these metals in pipes. And if the chemistry of the water changes just a little bit, then metals can come out of these pipes. And that's the problem that they had up in Michigan with the municipalities changing slightly the pH of the water that was being delivered to houses, and suddenly the lead came right out of those pipes and poisoned all those people. So that's again, this diagram here goes a little bit beyond runoff, but all of these things are pointing downward, and they're all going back into the river is what that means, into the groundwater and then eventually into the river. Okay, so this is a little bit of a change, and I'm done with that first slide and dissecting it a little bit. Just like I did with the air pollution, after I talked about all the different types, I wanted to talk about problems, and problems is a bigger concept than just a type or a source. As a matter of fact, a problem can involve multiple types and multiple sources. So I have 5 major water pollution problems that I'm going to talk about here, and the first one is eutrophication. Eutrophication. Anything that starts with an EU is usually a good thing. So it's usually something that's trying to make the best situation out of a bad situation. But in this case, the good is a bad thing because this is good for photosynthesis. It's good for algal growth in aquatic systems, and it's so good that it's too good. So what it is when we use fertilizers, when we dump sewage, when we use phosphate detergents, we are putting chemicals into the water that algae need in order to grow. When we learned about photosynthesis, we learned that nitrogen and phosphorus and potassium were really important nutrients. And fertilizers are full of nitrogen, and phosphate detergents are full of phosphates, phosphorus, and also potassium. And so we're basically giving these organisms the chemicals they need to just go crazy, growing and reproducing and spreading throughout this system. So what happens is when we're dumping these nutrients into the system, we end up with a lot of those algae growing in the system, and then it's not just that they're growing, but they grow so much that they block off the light at the surface. So there's no light down below, and as a result, there's no photosynthesis down below, and as a result, everything down below dies. Okay, so it looks great and lively on the surface, but everything below it is dead. So we say that we have increased aquatic primary production in the form of algae. It could be bacterial, like blue-green algae like cyanobacteria, or it could be, slimy kind of pondweed stuff growing on the surface. So what happens is it is overproduced and blocks off the light, and then it dies and sinks to the bottom and decomposes, and the bacteria that help decompose it use up all the oxygen. So everything dies from lack of light, and then everything dies from lack of oxygen in the water. And so we end up with what they often refer to as a dead zone in the water, because after this stuff has sunk to the bottom and the oxygen gets used up by it, there's no way for anything else to live in the water down below. So this is eutrophication, and basically it's a killer. If you've been to a golf course where they use a lot of fertilizers and a lot of chemicals that keep the grass really green, one of the things they have to do at a golf course is they have to put pipes down into the bottom of those water hazards and bubble water up, bubble air up through a pipe. And what that does is it keeps the water mixing so these nutrients get spread out. It is an effort to avoid eutrophication. If you were to just have all that fertilizer on the golf course running into the pond and then just sitting there, it would get green on the top like this, and it would get nasty and stinky and dead, and nobody would want to play golf anywhere near it. So that's what they're doing in order to prevent that. But it's happening elsewhere, including all throughout the agricultural states where all this fertilizers are running into the river and sewage. And so we have a big problem with it. Here we have a good example of that big problem. This is spreading fertilizers, chemical fertilizers, into crop fields. And these crop fields are all throughout the Mississippi River watershed. And then the Mississippi River flows right down this way, and I can't, yeah, okay. So it flows right out on that delta right there. And what you can see is that during the winter, there's a lot of primary productivity that's happening right near the shore because of the fact that there are a lot of nutrients in that water. And so we get algae growing in the shore. But during the summer, it goes crazy. The primary production is huge. And as a result, we see this bright satellite image of all the algae that's growing. And what happens is that entire region of the coast of Louisiana and Alabama and Mississippi, that entire region is dead. There's nothing there. That if you're going to fish in that region, you have to take your boat out beyond that in order to try to catch some fish during the summer. It's one of the reasons I wasn't too freaked out when we had that big oil platform accident there, because they were saying, oh my gosh, it's going to kill the fisheries, it's going to mess up the fisheries. And I was like, are you kidding me? Those fisheries are killed every year, and we've been doing that for decades at this point. So it wasn't really that scary a situation for me when I was thinking about it at the time. Anyway, this is a good example of eutrophication. Okay, so here is number 2 of the 5 major water pollution problems. And this is another big word. Before it was eutrophication. This is biomagnification. And this is usually from industrial or agricultural release of chemicals. So what is biomagnification? Well, it turns out that if there are toxins in water, even if they're at a very, very low concentration, very low parts per million, what happens is some of them, not all of them, but some of them can be picked up by organisms that live in the water. And if these are chemicals that are very persistent or lipid soluble, then they'll be picked up by an organism. And if another organism eats that first organism, then this chemical will become more concentrated in the body of the eater. Okay, so what we have here is water with some mercury in it, and then the mercury gets picked up by some algae, and then some tiny insects eat the algae, and they get a little bit more mercury in their body, because what they're doing is they're concentrating. As they eat more and more, it becomes attached to the internal parts of their body, to the lipids in their body, and it builds up in concentration. So then we have some insects that eat the insects, and it gets more concentrated. Then we have some little fish that eat the insect-eating insects, and it gets more concentrated. And then finally it gets to a big fish and to humans, and by the time it gets to humans, look how concentrated it is. And mercury is a very toxic material. I don't know if you've heard these types of warnings, but sometimes they will say that you should limit the amount of fish that you have in your diet. Not that those omega-3 fatty acids are bad for you, it's that the heavy metals end up, especially in large fish like tuna and things like that. They say women should not eat, when they're pregnant, they should not eat tuna more than 3 times a week. I don't know that I would ever eat tuna more than 3 times a week, but in some places that might be a big part of the diet. So I got some indications of examples here. DDT is a chemical that was involved in a pesticide that was used in the past. PCBs are, that's polychlorinated biphenyls, I think. Anyway, that was an industrial chemical that was used as a lubricant and as a conductor of electricity. Anyway, these are chemicals that were very, very commonly released into the environment in the past, and now it's illegal to release them, but they're still there. And so we're working at trying to get them out of the environment. Some of them are very dangerous, very carcinogenic. So mercury, if you remember, is a neurotoxin and causes developmental problems. So this is essentially the same diagram we were just looking at, except that it has numbers on it, and that made me very excited. So I thought that I would put this up so that you could see it. We're going to start with, and this on the left is a diagram for DDT, which was one of my examples, and on the right is a diagram for PCBs, which was another one of my examples. So anyway, DDT at 0.000003 parts per million in the water. And that's from pesticides that were sprayed on crops. Made its way into the water, but it's not very concentrated. Not something to get concerned about. But the zooplankton pick it up, and then they concentrate it to 0.04. And then the small fish eat them, and then it's concentrated to 0.5. Then the larger fish eat them, and it's concentrated to 2 parts per million. And now we're not going to put a human at the top of this food chain. We're going to put a bird that's eating a fish. And in that bird, in its tissues, we can find DDT at 25 parts per million. That is biomagnification. On the right, we have the same pattern, except that we're talking about PCBs. And instead of what is that, an eagle? Instead of an eagle, we've got a herring gull. So we start in the water. Actually, they're not giving us the water, but they are starting us out with the phytoplankton, 0.025, 0.123 in the zooplankton, 1.4 in the small fish, 4.83 in the larger fish, and then 124 parts per million in the eggs of the herring gull. And this is important that they're showing birds, because it has a lot to do with how we ended up getting away from using these kinds of biomagnification chemicals. There was a time when DDT, PCBs, these chemicals were very, very popular. So popular, in fact, that they were throwing them everywhere. They were actually using them on school kids at school, and they were using them on products around the house, and they were using them industrial. They were throwing DDT everywhere. They were spraying it on fields so much that the agricultural agencies had ads that said, DDT is good for me. Everybody was happy about DDT because it was killing pests. It was killing insects. And they used it to treat lice and things like that. Anyway, this is typical of the kind of ad that you might have seen for DDT, but it is a very, very dangerous chemical. And the reason that we know that today, or the reason that it was brought to our attention, is one of my favorite ecologists. This is Rachel Carson, who wrote the book Silent Spring. I may have mentioned her before. She's a favorite of mine for a bunch of different reasons. First of all, she was kind of an environmentalist. She actually lived in Maine for quite some time, and she loved living in Maine. She was an advocate for the environment, and she wrote this book, Silent Spring, in addition to some other books, and she caught holy hell for it because it was not what the industry wanted to hear. And the message in that book it was about birds. That's why the bird examples were important here. The message in that book was that if we continue to use these chemicals, then eventually things are going to start to die at higher trophic levels, and we may end up coming to the spring sometime, the spring season, and we won't be able to hear any birds singing. Because one of the things that this DDT does is it makes it so birds' eggs they don't create viable chicks. They just fall apart. So the birds reproduce, but then their chicks don't survive. Anyway, that's what the message was in that book, and talking about a lot of dangerous chemicals, but especially DDT. And it was not a well-received message. And it was years after she died that the courage that she had and the genius that she had became so important to us in terms of the environmental movement. This is just an indication of how incredibly popular DDT was and the kind of fight that she was facing. This is actually an advertisement for wallpaper that you would put in your child's nursery that was laced with DDT. Great thing to have in your child's nursery because, wow, we don't want any bugs in the nursery. That would be bad for the child. Anyway, if they were trusting it this much, then you can imagine how incredibly controversial this particular book was. Rachel Carson is very often held up as really the person who got the environmental movement really started in those late 60s, early 70s. So that was biomagnification. And this is moving on to number 3 in the 5 major water pollution problems. And this actually is one that I brought up as one of my primary sources, so I've been talking about it for a while. This is toxic runoff and leaching. And what kinds of things do we see here? Pesticides, herbicides, agricultural runoff, runoff from urban areas, oil spills, PAH, that's polycyclic aromatic hydrocarbons. That's basically when your car drips oil from your crankcase and the rain falls on it and it goes down into the grating. Those are the nasty chemicals that are traveling with it from roads, from parking lots, leachates from mining, from landfills. Lots of carcinogens, lots of teratogens. Those are the chemicals that influence early development that cause birth defects. And so a lot of big concerns here. The problem is that almost all of these are what we refer to as non-point source pollutants, which means they're coming from everywhere. So they're very, very hard to regulate. It may seem at times that we say, look, there's a pipe and the water from the city is all running through that pipe into the river. Well, there's the point source right there, right? But that's not the point source. That's just what we depend on to not cause a flood in the city. If we were going to cut that off, we would all be up to our knees in water. Anyway, it's a big problem, and it's one of the most difficult to regulate. There's a nice diagram of it down below here, and it has some of the major, I know you can't read the text, but it has some of the major sources. We have agriculture, forestry, we have homeowners here, we have the factories, and we have the schools and the highways and transportation, spraying on crops. Anyway, non-point source, all ending up in the same place. Very difficult for us to get a handle on. And so this is one of the ones we're scratching our heads on the most. And it says right here, polluted runoff ends up in the water, and this is the only growing source of pollution in the Potomac River watershed, which is the river that flows right through our nation's capital and flows into Chesapeake Bay. Chesapeake Bay is what we're looking at here. And anyway, it is the only growing source of pollution, which means we have regulations that are controlling all the others. So this is a problem that we're still working on and trying to figure out. Here's another little diagram that I kind of like, and there's not a lot more detail here except that you can actually read it. And what I want to make sure you understand is many, many, many sources all flowing into the same place. Very difficult to regulate, very difficult to get your hands on. For me, one of the most surprising problems with runoff, not just from agricultural areas, but from urban areas and from suburbs now, is that we engage in the practice of actively spraying poisons on the ground, as if it's just going to stay there or disappear somehow, as if it doesn't get into the water. And we all know it gets into the water, and it's still part of our normal cultural practice. So I have a quick list here. Pesticides that are used to get rid of any kind of animal that we don't like. Insecticides, which are pesticides that are specifically about getting rid of bugs. And I've put DDT in here. I don't know if you've heard about colony collapse syndrome. This is all the honeybees that are dying off, and this is because we're spraying our crops with nasty chemicals that are killing insects, and honeybees are insects. Brilliant. Anyway, but it is, like I said, spraying toxic chemicals on the ground on purpose. Herbicides that are weed killers. Yeah, I know it's not killing animals, but it's still toxic material. And then fungicides. And in this class, we've talked about how the fungus that's in the soil is really important to the plant. So if you're spraying something on the ground that could potentially kill fungus, I don't know how we can't see where that's going to go. Anyway, this is a big problem. It's not just about, oh, I don't know what to do with this material. We are actively putting these chemicals into water runoff that goes to our rivers. Okay, so I had to turn on my light here because it was getting dark. So if my little picture looks a little different, that's why. This is number 4 of my 5 major water pollution problems. And I've labeled this biomedical waste. I guess that's probably a little bit misleading, because I think when people hear the word biomedical waste, they think about syringes and gloves and stuff in a landfill, but that's not what I'm talking about. I'm really talking about biomedical chemical waste. And it's not really waste in the way that we think about waste. It's waste in the sense that we take active biomedical compounds and then use them and then pee them right back out and flush them into the river. It says here 90% of consumed prescription drugs ultimately end up in our wastewater. I put this diagram in here that I showed you before, which was a diagram of endocrine disruptors. I couldn't find a good list of drugs that end up in the drinking water. I think there's probably a lot of proprietary protection of companies when it comes to this. But there were phytoestrogens was a good example, and many of the chemicals that are in those drugs operate in a similar way. And I did find some kind of meme-worthy pictures of drugs ending up in drinking water. I just want you to be aware of it, that when there are persistent organic chemicals and heavy metals that are in drugs for very good reason, they can become concentrated in as a waste chemical in the flow of water back into the river. So we need to be aware of this. Number 4 in my list of 5. And finally, number 5, which is oil spills. And this is clearly a water problem because oil ends up sitting on top of the water. When we have an environmental disaster like a ship sinking or an exploding platform, clearly this oil ends up in the water, on the beach, in the rivers. Even when we have pipelines going across the land and they're leaking oil, that ends up in the groundwater, and that's a problem as well. So oil spills are a really big problem, but the biggest problem about oil spills is probably not the way that you think it is. Oh, I'm sorry, this is more pictures of what we think it is. Here we have oil spilling from a big platform, and it's even burning on the surface of the ocean, I guess. And here's a ship that's trying to help clean it up. There's a boom in the water here, which is a long line of floats with absorbent material tied to them so that they'll soak up some of the oil. This is where it ends up on the beach because it washes up when the tides go up and down. Clearly not going to be a popular place in this touristy area for quite some time because of that oil. So this is the problem that we think it is, but it's not what you think it is. This is to illustrate what's really going on. This is, first of all, it's not what you think it is because it might seem like it's getting worse and worse and worse all the time, but it's getting better. First of all, it's getting better. That's the thing we have to remember. This is according to a timeline, and we're looking back here in the mid-70s, and look at the amount of oil that was being dumped into water systems in the mid-70s. It was a crazy amount of oil, and look where it was. We're not even going all the way till now. This has taken us till 2016, and look how low it has gotten. So, wow, that's a fantastic improvement. But most of the oil that ends up getting into these water systems are still from a source that's not what you think it is, because look, if we look at this part of the pie here, it says land-based runoff. That's not an oil spill. That's not a big accident. That's not a tanker train exploding and making a mess on the land. That is your crankcase from your car, drip, drip, dripping onto a parking lot, and the rain comes down and it flows down the drain and goes into the river. 21% of all of the accidentally spilled oil is because of land-based runoff. Just runoff, not accidents. The accidents are actually this piece that's slightly smaller, only 18%. Industrial accidents, exploding platforms and ships sinking and all those, only 18%. So less than from the drip, drip, drip of the crankcase. Then we have air pollution, which we've talked about, 8%, and oil drilling. I guess maybe that's the floating platform, but the industrial accidents are the ships and the trains and things like that. So the land-based runoff is really bigger than any of those, but the big message here is that if you look at all the oil that's been dumped into the waterways over this period of time, almost half of it has been intentional. So companies that are transporting oil around the world, when it gets contaminated so it's not usable, it's often more profitable to get rid of it and then fill it with new oil. So there have been a lot of ships that have gone out into the ocean and dumped their entire cargo of oil. Intentional. Almost half of all of the oil spilled into waterways in the history of the earth has been intentional. So not what you think it is. And even if that were eliminated, even if we could keep track of everything and we just said that's never going to happen anymore, it would still be mostly from parking lots and cities and drippy crankcases. It would still be that. So not what you think. So anyway, I'm done. That is my lecture on water pollution, and I have gone through the major types and gone through my 5 major problems. I'll put up some homework that goes along with this, and it's Thursday night, so you should be able to get that done. And you won't hear from me until next Tuesday, when I'll probably be putting up some more lectures. But if you need to get in touch with me, please do so. I know I gave you a lab last week that involved a little bit of math, and I've actually helped a couple people with it, but I kind of expected more, and then I'm happy to help more. So I will be waiting for your call or your Skype or your I guess call or Skype is the information that I've given you. So or if you wanted to, we could have a Zoom meeting or something like that. I did a funny thing today. This is just me telling you a story. It has nothing to do with water pollution. I put up a video for one of my other classes where I was using one of the fake backgrounds in Zoom, and it was like a beach scene with the wind blowing, and I put in some wave sounds, and I was making announcements, and I actually had some of my students that thought I was at the beach. It's not that it was that convincing, it really wasn't, but I was sitting right here in front of my computer with like fake digital stuff, and I had some sunglasses on, and some of my students thought I was at the beach. Anyway, maybe I'll stick that up so you guys can see it, but it wasn't to you. I wasn't trying to fool you guys. Anyway, this lecture up, one more homework up tonight, and you get some time over the weekend to catch up, and we'll be doing a couple more lectures on Tuesday. I hope you're well, and I hope everything's going okay, and that I know it's not just about the virus, it's about people like having issues with their work and issues with their not being able to get the services that they need, and this is a stressful time. I don't think it's going to get easier anytime soon either. This is just a little bit of an aside, but one of the things they don't tell you when they talk about flattening the curve is that actually extends the pandemic. It makes it go on longer. And they don't talk about that, but it makes it safer because by flattening it, we have more hospital resources available. We don't have so many people sick that we can't deal with them. So we're dealing with them in the hospitals, and the cost of flattening it is it's going to make it last longer. Anyway, I don't think it's going away anytime real soon. We are already going to be all online for the summer, and my hope is that we'll have classrooms again with students in them and faculty teaching in the fall. And I hope to maybe see some of you then. Take care, be good, don't touch your face.